Hello and welcome to the Screencast, Modeling in Right Triangles with Tangent. Previously, we viewed the tangent function from the perspective as the tangent of theta equals the sine of theta divided by the cosine of theta, and we used that ratio to explore the properties of the tangent graph. In this video, we will look at the second perspective of the tangent function, namely how it relates to the opposite sides and adjacent sides to an angle in a right triangle. So a person stands at a distance from the base of the Matterhorn bobsled ride at Disneyland such that the angle of elevation from eye level, which is 5 feet above the ground, to the top of the Matterhorn is 20 degrees. The person then walks 195 feet closer to the base of the Matterhorn such that the angle of elevation is now 36 degrees. How tall is the Matterhorn? So to start, go ahead and sketch a picture of what you think is being represented here, and then we'll check and we'll move on. Okay, so we have the top of the Matterhorn here, and there's someone standing somewhere out here whose eye level is 5 feet, and the angle of elevation is 20 degrees. And then the person walks 195 feet closer, and now the angle of elevation is 36 degrees. Right, so this distance here was 195 feet. And we can imagine this right triangle. And we're trying to find the height, let's call that y, of the Matterhorn. And so you'll notice that we have two different right triangles. We have one right triangle with a known angle of 36 degrees, and then we have another known triangle, this larger one, with a known angle of 20 degrees. They share the same height y, but they have different legs that are adjacent to those angles. And so it would probably benefit us to go ahead and label this other side for that smaller triangle x. And ultimately we're going to use tangent because we have the side opposite the angles that we know, and we know some things about the adjacent side. So we're going to set up two equations here. First, if we look at the smaller triangle, we know that the tangent of 36 degrees is going to equal y divided by x. And so the issue here is that we have an equation involving two variables, y and x, and that's actually a pretty big clue that we're going to need a second equation because we have two variables right now. So we can look at the bigger triangle where we had the tangent of 20 degrees now. The opposite side is still y, but the adjacent side would be the entire length, so it would be 195 plus x. And so anytime we have two unknowns and two different equations relating them, if there's a solution, we should be able to find it. So we're going to take this first equation, we're going to multiply both sides by x. So we have the x times the tangent of 36 degrees equals y. And we'll go ahead and make a substitution. We'll replace y with this quantity, x times the tangent of 36 degrees. So we're going to have the tangent of 20 degrees equals x times the tangent of 36 degrees divided by 195 plus x. And our goal is to isolate x, but we see that there's an x in the denominator. So typically when the variable we want is in the denominator, we can get that out by multiplying both sides by the denominator. So now we have the quantity 195 plus x times the tangent of 20 degrees equals x times the tangent of 36 degrees. We'll go ahead and distribute on the left side. So 195 times the tangent of 20 degrees plus x times the tangent of 20 degrees. That will equal x times the tangent of 36 degrees. And then you'll also notice that we have an x term on both sides. Notice that that x term is being added. So we want to get the x's on one side, and we'll do that by subtracting. We'll undo that addition. So we're going to have 195 times the tangent of 20 degrees is going to equal x times the tangent of 36 degrees. And then, like I said, we're going to subtract x times the tangent of 20 degrees. And from here you can see that both terms on the right contain an x, so we can factor out that x, and we'll be left with the tangent of 36 degrees minus the tangent of 20 degrees. That would all be multiplied by x, and that would all equal 195 times the tangent of 20 degrees. Still, from here, we can divide both sides by the tangent of 36 minus the tangent of 20. So we're going to see that x equals 195 times the tangent of 20 degrees divided by the quantity tangent of 36 degrees minus the tangent of 20 degrees. So that's the x value, which just tells us how far away the person was from the center of the base of the Matterhorn when they walked 195 feet closer to it. But our question was, how tall is the Matterhorn? So we need to actually find the y value. And we're going to go back and we're going to use this quantity we found earlier. We know that y, which represents the height of the Matterhorn, equals x times the tangent of 36 degrees. And we know x is now this quantity. So what we could say is that the height of the Matterhorn, which is y, equals 195 times the tangent of 20 degrees divided by the tangent of 36 degrees minus the tangent of 20 degrees. That was all x. So then that has to be multiplied by the tangent of 36 degrees. So that would give us the height of the Matterhorn. That would be in feet. And that would be our exact answer. If you wanted to, you could multiply straight across and combine that into one fraction. That'd be fine. And then if you're curious what the height of the Matterhorn is, we actually could do a couple things here. If you put this into calculator or decimals, you'll find that y is approximately 142.222 feet. And then we actually need to be careful here. We forgot that the angle of elevation was from eye level, which was 5 feet above the ground. So I misspoke. This y value is not the height of the Matterhorn. It is just the height of this part of the triangle, but we have to keep in mind there was this extra 5 feet between the eye level of the person and the ground. So really, how tall is the Matterhorn? We would have to take that 5 feet and add it to our 142. So our final answer would be about 147 feet. That would be an estimate. Our exact answer would have been this expression here, and then we would need to add 5 feet to it to get the total height of the Matterhorn.